So, before we begin, go check out Carnivore Land. We are currently on Steam Greenlight. You will find the links in the description below, and go vote for us so that we can be on Steam. So, today in this video we will see we will see some examples for cameras in a 3D side-scroller game. Now, the controller I'm going to use for my 3D sprite to move around is actually the one we created in our very first video. You will find a link to it in the description below, of course. So, before we begin, we need to have, of course, a main camera, and we're not going to actually move the main camera as it is, but we're going to parent it under another object. And if you see here, now never mind, this is 3D level, that doesn't matter. So we're actually going to have the camera holder to have the same position as the sprite of our player over here. Okay, and the main camera will be actually further away. Now, however back I put the camera, it doesn't really matter since it's on orthographic projection. So we will go now. It doesn't it should be zeroed in actually, and we should take the Z a little further back or the other way around, and we might actually need to go even more back, and for some reason I'm not so the camera preview must have backed out. So if we hit play, we move around. Now let's go into our scripts folder. Now this is actually going to be more of a twin and interpolation video rather than moving the camera around, because we don't want to just use a lerp to move from position to position, so we'll also create some interpolation examples. So because we don't want to do it all over again and every time we have to write an interpolation, we can simply create a new script which let's just name it interpolation library. Let's open it up and let me bring this over here, and then now we do not want to use either the start or the update, so we're going to use some public static vector 3. So the first one will be public static vector 3, and we will rename this to acceleration, deceleration, interpolation. So it's not going to be like a linear interpolation where the movement is linear. It's going to actually accelerate, and then before reaching the target it's going to decelerate. Now this is going to have a lot of math, of course, and you can Google online. There are plenty of sites that you can find different interpolation equations to have your desired movement. So this vector 3 will take a vector 3 of start, a vector 3 of end, and a float which we will name t. So the first thing we need to do is find the difference between our end and start parameters. So we start by subtracting every point. let's subtract. So we have the difference between our end and start vector. Then we need a new t, which we'll do some math over here. Our mathf.cos is a math function, of course, which returns the cosine of angle f in radians. So this will take t plus 1 multiplied by mathf.pi, and all this will be subdivided by 2, and plus we will add the point f. Now this is the equation you will find online. Okay, you will Google it and find. So after that we need to multiply our x, our y and our z with the new t, and then simply create a return vector which will equals new vector our starting x plus the x, our starting y plus y, and our start z plus z. And of course we actually have to return this return vector. So this is one example of acceleration and deceleration interpolation. Let's quickly create another one. So let's create this to be only acceleration interpolation. This will take start, this will take an end, a float, and a float of a factor. Now we will also need this, and we will also let's create it in a second. So we need a new float, the same as before, be a new t, which is going to be the t, and then we now need to create a new function that is going to hold our statement, is going to check a statement, because we can say if a float, let's say float f, or if we had a float f, or maybe yet let's just use the new t, equals 1, because the float might be 1.001 or 0001 and stuff like that. So we need to create the statement. We will create it in a different way. So let's go back and let's create private static bool. Let's say float equals, and this will take one float and a float here too. So over here we simply need to return the absolute value of f1 minus f2, and if all this is under the 0.1 f. So over here we do the check, and we will pass our factor and the 1, and if it's under, then we multiply the new t by itself, else we raise the f to power the p. So we call the mathf function of .po, we pass the new t, and we pass R factor multiplied by 2. And then, as before, we add this and a return vector. So this is two examples of how we can move around our camera. So let's jump back into Unity. Let's create a new script, or maybe yet let us go to our player and let's open our user control. Okay, this is the same as our first video, but with only changes over here so that it can work in Unity 5. Okay, everywhere you saw in the past rigid body 2D or renderer, you have to store the functions over here and just use this and this. So the first thing we know we're going to do is we need public transform, which is we're going to call it camera holder. And since we know our camera holder is going to be a child of our camera, we can do camera.main.transform. Or maybe this the main is a transform, so no, it's not. Transform.parent or transform. Okay, so we don't have to drop it from the inspector. Now let's create our camera movement. Maybe yet. Let's create a public enum, which we're going to say movement, or maybe camera movement type. And then we can write the cases we want where we can move our camera. So the first is going to be a lerp, the second is going to be a move towards, the third is going to be accelerate, decelerate, and then simply acceleration. Let's create a public camera movement type. Let's name it camera movement type, so that we can set it from the inspector. So let's create a new function. Let's call it camera movement. So we need to have a switch, and inside that switch we need to pass the camera movement type and make our cases. So for case camera movement type dot lerp, case camera movement type dot, this needs to be a capital, camera movement type dot move towards, break, another case for camera movement type dot acceleration deceleration, and a last one for camera movement type dot acceleration, and we need to break. So let's add a public float over here, which we'll call it camera speed. And let's go into a lerp. So if the case is a lerp, then not transform dot position, the camera holder dot transform dot position will equals vector3 dot lerp camera holder dot transform dot position. The target position will be our transform dot position, and we need to pass time dot delta time multiplied by our camera speed, and that is the lerp. Now for move towards, it's actually going to be the exact same, but with move towards, the last parameter, the t, this one over here, on a lerp, this is a percentage. Okay, on the move towards, it's not the percentage of how much it is between 2 points, it's how much based on a distance. So for the other two cases we created, we will pass camera transform dot position will equals, and now we can call our interpolation library, and we will say acceleration, deceleration, interpolation, and pass the starting, which is camera holder dot position, our transform dot position, and the float t will be time dot delta time multiplied by speed moved by camera speed. Okay, and for the last part, which is simple acceleration, we change the acceleration deceleration, we will change it to dot acceleration interpolation. The start will also be the same, the target will also be the same, but we need to pass the factor, which we just passed a factor of 1. If we save now, the only thing we need to do is take the camera, this function, and just drop it inside update. And if we hit play, let's see what's happening. Of course, we have camera speed to 0, so let's make it to 1. So we're seeing we are moving now with a simple lerp. If we use move towards, now you probably won't see too much of a difference, and if we use the acceleration deceleration, we see the movement speed. So let's make it something like 5. You will see that the camera decelerates before it reaches its target, and I almost forced over there. Okay, and if we use acceleration, you see that it actually has a different behavior. It uses more with acceleration. So this is the basics of how we can move our camera around. Of course, you can make more interpolations and decide what you need to do, but as you can see now, mostly in games, you will see that it actually do not always move like this. So whenever the player is moving, it doesn't always move like that. So there's a great presentation about the camera movement, which you will find a link in the description below. Okay, so you can decide how much you can decide which one you need to use for your game. Let's see 2 examples here though. So the first example was that the camera was moving only if the player was going out of a little imaginary box over here. Okay, so let's see that. So instead of just dropping it inside update, or maybe yet, let's just leave it there. So let's take a float which we'll call distance from camera, and then we will pass vector3 dot distance, and we will pass the camera holder dot position and r transform dot position. So we can do a check if distance from camera is greater than 1, then only then call the camera movement. So let's make this something like 2 so that we can take a look at it. So over here, if we hit play, you will see that only if I move, we forgot the camera speed, let's give it 5, let's make it acceleration deceleration. So only if I move further away from the camera, then the camera will move from that imaginary box. So if the position of the player is greater, the distance between the camera holder and the position of the player is greater than 2, only then it will move. But you will see that if I jump up, then the camera will stay up. So in order to change that, let's create a new bool which we'll call move camera, and then on update, instead of using straight the function, we will say if move camera, then call the camera movement function, and over here we will say if the distance is greater than 2, we'll say move camera equals true, else if distance from camera, if the distance from camera is lower than, let's say, 0.1, then move camera equals false. And let's test this. So if I'm under the 2-point barrier, the camera doesn't move, but if I move, the camera will follow me until its distance is lower than 0.1. Of course you can go even lower, but this looks pretty good. So this is one example. Now let's see another one. And the other one was that if the player jumped and hit on an object and he was on the ground, and only then the camera will move and follow him around. So the next thing we can do is, if I remember correctly, we had, or we didn't, I think it was the jump key down. So let's add if the distance from camera is greater than 2 and the jump key down is false, only then move the camera, else we'll leave the same. So let's hit play. So if I jump, no, it follows around, because so it's not that. So let's create a new, let's do it another way. Let's instead of using jump key down, let's delete this, and then let's create a new boolean. We'll do it the simple way, which will create a new boolean on ground and say if the distance from camera is greater than 2 and on ground is true. Let's close this. and let's create the on collision enter 2D, and we'll pass a collision 2D, and then if now, since we do not have any other collider, we can only collide with the ground over here, then we don't need to do checks to see what we hit. We know we'll only be hitting the ground. Of course, if you have more colliders and enemies, stuff like that, you will need to add the check, and on enter is true actually, and then on collision exit 2D on ground equals false. Let's save, and let's see now what we can do. So you see that even if I jump way up to the air, the camera doesn't follow me around. So now, of course, this has a little let's see, if I jump now, even if I pass the two, if I jump and yes, so if the camera is moving and it hasn't reset its position back, and even if I jump, it will keep following me around. So we can change that by going inside update and then saying if move camera and on ground, and this will take care of that. Okay, now of course this might not be for all appropriate for all game or for all the Sidescroller games. Thus these are some examples on how you want to do. If you watch the presentation, you will see some more examples and you can decide what you want for your game. So this was basically it for our video. Thanks, don't forget to like and subscribe. You can go check out Carnival Land on Steam. You will find links below, and send us a vote. And you can support me on patreon.com/C#accent, where with $5 or more you can get access to a Google folder where I have all the scripts I make in the videos. And I'll see you next time. This week we were a little bit off schedule because of all the green light stuff and about our game's release. So expect our usual schedule from the weekend and after. So thanks for watching. Don't forget to like and subscribe, and I'll see you next time.